Hi there, welcome to video 8 on the exam questions in the AQA Higher Unit 3 paper on circles, okay? You should have just done video 7, which was a tutorial about everything you need to know about circles in the higher paper. You should have some revision cards based on that video, and now you should be ready to answer the following questions that come up in regards to circles in the Unit 3 AQA Higher. As always, I'll show you a question, pause the video. After 10 seconds, I'm going to start working through the question, but you must have an attempt yourself and see if you're getting the right answer. Afterwards, mark it and check what you got. Let's look at the first question. Pause the video. Okay, they want you to work out the circumference of a circle with diameter 9. The circumference is the distance around the outside of this circle, okay? And the diameter is 9. So always start off by writing what your radius is. Your radius is therefore 4.5 centimeters, which is half the diameter. Okay, you need to remember the formula for circumference. Circumference is 2 pi r. You must remember that. So, in your calculator, type 2 times pi times 4.5 and see what you get. So, 2 times pi times 4.5, and I get 28.3 centimeters to 1 dp. It doesn't tell you what to round it to, you can leave it like that. If you left it in terms of pi, an equivalent answer would be 9 pi centimeters. So that would be by just doing the 2 times the 4.5 and writing pi afterwards. So both of these are acceptable, but I'm going to write 28.3 centimeters. Okay, next question. Pause the video as always, try the question. After 10 seconds, I'll go through. Okay, so going through this, you had to tick a box here. It's a 2 marker ticking a box. You should be able to work these ones out by yourself. It's a bit strange question, but if you just think it through, it should be easy marks for you. The circumference of a circle with diameter 10. Well, the radius therefore would be 5. Let's work out what this circumference would be. The circumference would be 2 times pi times r, which is 5. And if I type that in my calculator, I would get 2 times pi times 5. I'd get 31.4 centimeters. So, therefore, the statement is, the circumference of a circle is greater than the perimeter of a triangle with base 10. Is this always true, sometimes true, or never true? Well, we have a circle here with circumference 31.4. Let's try and draw ourselves a triangle, okay, with base 10. Can we make that triangle bigger than its perimeter, bigger than 31.4? Well, of course we can. We could have made this 20, say, and that 20, and we would have got way over this. So it is certainly not always true. Okay, the circumference is not always bigger, because that could be 20 and that could be 20, and therefore our triangle is bigger. So the question is, could it sometimes be true? Well, if we had our base as 10 again, if we had our base as 10, could we construct a triangle so that it was less than 31.4? Well, look, we actually, in theory, could, because what if I chose these distances here to be, let's say, 6 and 6? Okay, this would certainly be a triangle because these two add up to more than this one, so they would meet. So if that was 6, that was 6. The total perimeter here would be 22 centimeters. So the circle can have a bigger perimeter than the triangle. Okay, so this is sometimes true. Okay, it's certainly not always true, and it's certainly never true, so sometimes true is our answer there. Okay, next question. Pause the video as always, have a go. Watch my answers, mark your work, and check if you're getting it right. Let's take a look. Okay, this question is all about circles and it's dressed up in a problem about garlic bread, okay? So, what it says is, Robert was going to order a 14-inch pizza. Okay, so he was going to order this pizza here, okay? And then he saw a special offer, and the special offer said that you get one 7-inch pizza or garlic bread and one 10-inch garlic bread for the same price as a 14-inch. And because 7 plus 10 is 17, 17 is bigger than 14, if Robert takes this offer, he's thinking he will get less garlic bread than just ordering the 14-inch garlic bread. Is he correct? Well, this question is a question of areas, okay? So, what we would like to work out is the area of 14-inch pizza. Okay, now 14-inch is the diameter, so the radius is 7. So the area is pi times 7 times 7, which you could work it out on your calculator or leave it as 49 pi, and it's inches squared. Okay, that's how much you'd get if he had ordered the 14 inches. Now, area of 7-inch pizza. Well, r this time is 3.5, so we do pi times 3.5 times 3.5, and you would get 49 over 4 pi inches squared, and the area of the 10-inch, well, r would be 5 here, so you would get pi times 5 times 5, which is 25 pi inches squared. So if you add this one to this one, and you work out as a decimal, the two add up to 117 inches squared. But this one here, 49 pi, adds up to 153 inches squared. So if Robert takes that special offer, the 17 plus the 10 inches, and he pays the same as he would for a 14-inch pizza, he is getting less garlic bread. So Robert is correct. Robert is correct. Okay, because 153, the amount he gets in a 14-inch pizza is bigger than the 117 inches squared, the amount he'd get in the other two, and he's paying the same price as for a 14-inch pizza. Okay, as always, next question. Pause the video, have a go. Okay, the diagram shows the sector of a circle. The radius is 30 centimeters. It says work out the arc length of AB. So here we just got to be careful what we want. We want the curved part of the circle AB here. We want that distance there. Give your answer in terms of pi. So we've talked about that in the revision tutorials. Well, we don't care about the 60 degrees. How much of the circle is in? How much of the circle do we have on this side? Well, we have 300 degrees. So the arc length, the length, is therefore the fraction of the circle we have, which is 300 over 360 times 2 times pi times r, which is 30. Okay. If we work that out on our calculator, everything apart from the pi, if we did 300 divided by 360, then times 2, then times 30, and forget the pi, we would get the length is 50 pi, and the unit is centimeters. So 50 pi giving our answer in terms of pi, and we're done. Okay, next question, pause the video, have a go and mark it. Okay, Fred is marking a sector of a circle on the sports field. He puts tape around the perimeter. How many rolls does he need? Blah, blah, blah. The perimeter, the distance we're interested in this curved distance, but also here we're interested in the two radiuses added in there. So we've got a part of a circle. We've got the radius is 40 meters, and we've got 50 degrees of the circle. So what is the distance around the circle? So let's work out the arc length first of all. Arc length. Okay, well we have 50 out of 360 of the circle, and we're going to multiply that by the circumference of a whole circle, which is 2 pi r, so 2 times pi times 40, and we're going to work that out. So tap that all in the calculator, and you get 34.9 meters, and then so total perimeter must be the 34.9 plus 2 radiuses, so 2 radii, the 40 and the 40, so plus 40 plus another 40, and you would get 114.9 meters. Now that's the total distance. Tape comes in 3 meter rolls, so how many rolls do you need? So rolls would be 114.9 divided by 3, and you get 38.3 rolls. Now you can't have 0.3 of a roll, you're going to have to buy more rolls than that, so you would have to buy 39 rolls. And there we have the answer for 5 marks. Quite an easy question really. Okay, again, next question, pause the video, have a go, mark your work. Okay, it says the diagram shows the major sector of a circle with radius 8 centimeters. The major sector just means that it's big, okay? So it's this big one here. Work out the perimeter of the sector. Well, perimeter of the sector is the curved distance here, but don't forget we're going to have to add in this distance and this distance. They haven't asked us for the arc length, they've asked us for the perimeter of the shape, so therefore it includes the 2 radii. Okay, so let's work out the curved length first of all, as we always do. Curved. How much of the circle do we have? We have 280 degrees out of 360, and we're going to times that by 2 pi r, so 2 times pi, and the radius is 8. I'm going to tap that all in our calculator, and we're going to get 39.1, and the unit is centimeters. Now, to get the perimeter, we have to add 2 lots of 8, so therefore perimeter is therefore 39.1 plus the 8 plus another 8, and we would get ourselves 55.1 centimeters. Simple as that. Nice, easy 4 marks. 55.1 centimeters. Okay, again, look at the next question, pause the video, have a go, mark your work. Okay, it says that the diagram shows a semicircle, radius r, and a rectangle. The perimeters are equal, work out the value of r. Well, what's the perimeter of this semicircle, the whole semicircle? So that must be the curved distance, okay? But also don't forget the perimeter means you have to add on 2 of the radii, okay? So this here, well, the curved distance of a whole circle is 2 pi r, so half a circle must be pi r, and you need to add 2 lots of the radius, so 2r. That's the perimeter of this shape here. Now this shape, well, this must be r because it's a rectangle, and this must be 3, so the perimeter of this shape must be r plus 3 plus r plus 3, or you can do it in any order. R plus r is 2r, and 3 plus 3 is 6. So that's the perimeter of this semicircle, that's the perimeter of the rectangle. We are told their perimeters are equal, so pi r plus 2r must be equal to 2r plus 6. Simple as that, right? Then we have to solve this equation to find r. Well, we've got 2r on both sides. If I subtract 2r off both sides, I would get pi r. 2r subtract 2r goes. 2r subtract 2r goes. I would get pi r is 6. So r, therefore, if pi times r is 6, divide both sides through by pi, and we would get 6 divided by pi. So the value of r is 6 divided by pi centimeters. Okay, or if you wanted to work that out accurately, you do 6 divided by pi, and if you left your answer to 1 dp, that might be 1.9 centimeters. Okay, next question. Pause the video as always, try the question, mark your work. Okay, so in this question we're asked the area of this shape. Now I've actually done this question in the trapezium section, so I'm not going to go into the trapezium that much. It's the area of a semicircle plus the area of a trapezium. Now this circle here has diameter 30, so it has radius 15. So the most important thing here I care about is the area of semicircle for this video. So it's going to be a half times pi r squared, pi times 15 times 15. Okay, because a whole circle would be pi times 15 times 15, and then I'm halving it, okay, to get a semicircle. So pi times 15 times 15, and times it by half or divide by 2, however you like to do it, I would get 353.4. So I get 353.4 millimeters squared. Now the area of 2, that's a trapezium. Parallel sides 30 and 40, perpendicular height 20. So the area of that, you do it in stages. You add the parallel sides, so you do 30 plus 40 is 70. You halve them. 70 divided by 2 is 35, and then you multiply that number by the distance they are apart. So times 20, you get 700 millimeters squared. So 1 plus 2 gives you 1053.4 millimeters squared, which is 1050 millimeters squared to 3SF as required. Okay, just take a look at the next part of this question. It doesn't really link into circles that much, but just finish it off for the sake of it. Again, I've done this question in the trapezium section, so you could look at it in more detail there. Pause the video, have a go, take a look at the answer. Okay, so we know the area of the trapezium, what was it, 1050? 1050 millimeters squared, and it says the steel costs that much per millimeter squared. So steel must cost 1050 for each shape times 0.05, which if you work it out should be something like 52.5p, which if you change into pounds would be 0.525 pounds. Okay, so that's the cost per shape. So for 4,000, it would be 4,000 multiplied by 0.525 you get £2,100. And don't forget, it also says that they use some zinc to prevent corrosion, 3p per shape. So the zinc cost must be 0.03, that's 3 pence, or written as pounds, 0.03 pounds multiplied by 4,000. Get 120. You add those two up and you would get £2,220. £2,220, and there we go. Okay, take a look at the next question. Pause the video, have a go. Okay, so although it doesn't look like a circle question as such, it is involving some of the circle theory we've talked about here. The diagram shows a cylinder. The diameter of the base is 14 centimeters. So that's saying that this distance here, the diameter, is 14. So the radius must be 7 centimeters. And it says the height of the cylinder is 12 centimeters. So the height is 12 centimeters. It asks you for the volume of the cylinder, and it says give your answer to a suitable degree of accuracy. And we've got 4 marks. It gives you the unit centimeters cubed. Okay, what's this got to do with circles? Well, you should look at the front of your formula booklet, and it tells you something helpful about how to work out the volumes of certain three-dimensional shapes. It says that the volume of a prism is the cross-sectional area times its length. So it's the front area here times its length. Now, actually, a prism should have straight edges all around, but it doesn't matter for the purposes of this exam. So if we have a prism that is a shape, a three-dimensional shape, that if I cut it along its length, it looks the same at each point. To work out its volume, you work out the area of the face and you times it by the length. This works as well with cylinders. So what we need to do is work out the area of its face. So the area would be pi r squared because it's a circle. So it would be pi times 7 times 7. Okay, in terms of pi, we can leave it for now 49 pi. That's the area. So the volume is always the area of the face times the length, or the height in this case. So it would be 49 pi times 12, which when you work it out on your calculator, you get 1847.26, and the unit centimeters cubed. Okay, so it's simple as that. Now, there'll be 1 mark for a suitable degree of accuracy. Now, the question, the lengths given to us in the question are to 2 significant figures. 2 significant figures. So the best thing really to give back here would be to give the answer to 2 significant figures. The first significant figure is the first number we see. That's the second. Put a line after it. Because this is a 4, we just round off, and I would round it off to 1,800 centimeters cubed, and I would write I've done that to 2 significant figures. Okay, if you gave your answer to 2dp like here, you'd lose a mark because the answer is too accurate. You weren't given the lengths to 2 decimal places in the question, so you shouldn't give your answer to 2 decimal places. Okay, next question. Again, pause the video, have a go. It's using cylinder knowledge as well. Have a go and see where you can get to. Just before we do that, I'm going to show you the question here. You've got to work out the volume of that test tube, but a little tip for you, you would look in your formula booklet, you would use the volume of a prism again to help you, and also the formula booklet tells you the volume of a sphere. A sphere is like a 3-dimensional ball. That's how you work out the volume of a sphere. So maybe you could combine the volume of a cylinder with the volume of half a sphere, see if you can work out the total volume. Pause the video, have a go, and mark your work as I go through it afterwards. Okay, let's have a go at this then. I'm going to do it in two sections. I'm going to call the cylinder part of the test tube part 1, and I'm going to call the hemisphere is half a sphere, part 2. So, for part 1, the volume of a cylinder is the area of the face times the height. Now, just a tiny little bit of work needed here. This cylinder here must have diameter 6 because it's the same as the top. So that means it must have radius 3. So this distance here must be 3 centimeters. So that means that distance from here to here must be 9 centimeters. Okay, so for part 1, area of circle, I'd start off with circle, get some marks. Well, the radius is 3. So it's pi times 3 times 3, which is 9 pi. Okay, so the volume of the cylinder is therefore the area of the face, 9 pi, times the length, which is 9, and you would get 81 pi. And that's the volume of part 1. Part 2. Well, a whole sphere, okay, is 4/3 pi r cubed, which would be 4/3 times pi times 3 times 3 times 3, which would give you 9 pi. 36 pi even, 36 pi if you work that out. But you want half of that because you only want half a sphere, so you would get 18 pi centimeters cubed for that. So adding them together, I would like to add the volume. I would like to add the volume of the cylinder, which is 81 pi, and the volume of the hemisphere, which is 18 pi, and together I would get, so 1 plus 2 would be equal to 99 pi, the total volume, and leaving my answer, say, to nearest whole number, that would be 311 centimeters cubed, and that would be rounded to 3 significant figures. Okay, so the key to that question was break it down, work out the volume of the cylinder, work out the area of the circle, and times it by the height. To get the height, you just had to be careful and realize that if a sphere had diameter 6, it had radius half that, which is 3, so this height must be 3. So the height of the cylinder must be 12 take away 3, which is 9. Get that, and then work out the volume of a whole sphere by using 4/3 pi r cubed, which is in your formula booklet, and then halving it to get 18 pi. Add that, and you've got your entire volume. I hope you found the following useful in your revision of circles for Unit 3 higher. So just to make sure, go back over the first video if there's anything you're stuck on. Make sure you've got all your formulas that you need to know, and you also are getting familiar with how to work out volumes here, okay? Because the circle questions sometimes do tend to come up in a volume question as well. Thank you for watching, and see you in the next video.